For generations, humanity has built larger and more powerful telescopes to answer one fundamental question: how does the universe truly work? Every breakthrough has revealed something unexpected, from distant galaxies to planets orbiting other stars. Yet the greatest discoveries often begin with a mystery that no one was looking for. The James Webb Space Telescope was designed to peer farther into space than any observatory before it. Its mission is to study the first galaxies, examine the atmospheres of distant worlds, and uncover clues about how the universe evolved after the Big Bang. But every observation Webb collects contains far more than beautiful images. Hidden behind every colorful photograph is an enormous collection of scientific data. Tiny changes in light, temperature, chemical signatures, and radiation are carefully recorded, creating a massive archive that researchers continue to analyze. Most of these measurements reveal exactly what scientists expect to find. Occasionally, however, the data raises new questions. As modern computing became more advanced, astronomers began using artificial intelligence to help organize and study these enormous datasets. Machine learning systems can recognize subtle relationships that would take humans years to identify. Rather than replacing scientists, these systems act as powerful assistants, helping researchers spot unusual patterns worthy of closer investigation. During several analyses of deep space observations, some algorithms highlighted relationships between distant regions of space that appeared statistically unusual. This did not mean something impossible had been discovered. Instead, it suggested that certain observations deserved additional study. One area attracting particular interest involved gravitational lensing. Gravity has the remarkable ability to bend light. When light from a distant galaxy passes near a massive object, such as another galaxy or a cluster of dark matter, the light curves before reaching Earth. Astronomers use this effect like a natural cosmic magnifying glass, allowing them to observe objects that would otherwise remain invisible. As researchers examined these lensing events in greater detail, they noticed that some distortions appeared more complex than expected. There were several possible explanations. Some could result from unseen concentrations of dark matter. Others might reflect the combined influence of multiple galaxies aligned along the same line of sight. In many cases, improved computer models eventually explain observations that first appear unusual. Still, every unexpected result provides an opportunity to learn something new. Artificial intelligence also began identifying recurring mathematical relationships within certain observations. This doesn't necessarily indicate hidden messages or unknown forces. Nature itself often produces repeating mathematical structures. Spiral galaxies, planetary orbits, crystal formations, and even the branching of trees follow mathematical principles that emerge naturally from physical laws. Finding patterns is therefore an important part of scientific investigation. The real challenge is determining whether those patterns represent meaningful discoveries or simple coincidences. To answer that question, researchers compare results collected by different telescopes, use independent computer models, and repeat their calculations many times. Only after careful verification can scientists decide whether an observation represents a genuine discovery. This process is slow, but it is also what makes science reliable. One exciting possibility is that future observations may reveal entirely new aspects of how matter, gravity, and light interact across enormous distances. Such discoveries would expand our understanding of the universe without requiring extraordinary explanations. The James Webb Space Telescope continues collecting data every day, and each new observation adds another piece to an enormous cosmic puzzle. Researchers know that many of today's mysteries will eventually have clear scientific explanations. Others may lead to entirely new fields of study. History has shown that some of astronomy's greatest breakthroughs began as tiny anomalies hidden inside enormous datasets. At first, they looked like simple mistakes. Later, they transformed our understanding of the universe. Today, scientists continue examining Webb's observations with increasingly sophisticated tools, hoping to separate genuine discoveries from statistical noise. Every new analysis brings fresh questions. Every new observation expands humanity's knowledge. And every unanswered mystery reminds us that the universe is still far more complex than we have yet imagined. As researchers continue studying data from the James Webb Space Telescope, one fact has become increasingly clear. Every observation contains far more information than scientists can analyze in a single study. With each passing year, improved software and more powerful computers reveal details that were impossible to detect before. That is why artificial intelligence has become such an important tool in modern astronomy. Instead of replacing human researchers, AI helps sort through enormous amounts of information, highlighting unusual observations that deserve closer examination. It can compare millions of measurements in a fraction of the time required by traditional methods, allowing astronomers to focus on the most interesting results. Sometimes those results confirm existing theories. Other times, they raise entirely new questions. One of the biggest challenges in astronomy is separating genuine discoveries from statistical coincidences. The universe is filled with complex structures, overlapping galaxies, clouds of gas, and invisible dark matter. These features can produce surprising patterns that initially appear mysterious but later receive completely natural explanations. This is why every potential discovery must be tested repeatedly. Scientists compare observations from different instruments, build computer simulations, and collect additional data before reaching any conclusion. A single unusual image is never enough. Confidence comes only after independent evidence points toward the same result. Even so, history shows that many revolutionary discoveries began as small anomalies. The expansion of the universe. The existence of black holes. The discovery of planets orbiting distant stars. Each of these ideas was once considered uncertain because the first evidence seemed incomplete. Only years of careful investigation transformed those possibilities into accepted science. Today's mysteries may follow a similar path. Researchers are especially interested in understanding how gravity shapes the largest structures in the universe. Webb's observations are helping scientists study galaxy formation, dark matter, and the behavior of light across billions of light-years with greater precision than ever before. Every new dataset improves those models. Every observation helps answer old questions while creating entirely new ones. Some people wonder whether advanced civilizations might leave detectable signatures somewhere in the cosmos. While this remains an interesting scientific idea, no verified evidence has shown that Webb has discovered artificial technology or extraterrestrial messages. Astronomers continue following the evidence wherever it leads, but extraordinary claims require extraordinary proof. For now, the telescope's greatest achievement is expanding humanity's understanding of the natural universe. Its discoveries have revealed galaxies that formed surprisingly early, provided detailed studies of exoplanet atmospheres, and allowed scientists to examine regions of star formation with breathtaking clarity. These achievements are extraordinary on their own. Yet perhaps the most exciting possibility is that Webb has only begun its mission. The telescope is expected to operate for many more years, collecting an ever-growing archive of observations. Future generations of scientists will analyze this information using technologies that do not even exist today. Questions that seem impossible to answer now may become routine decades from now. That has always been the story of scientific progress. Every generation inherits new tools. Every new tool reveals another layer of reality. And every layer reminds us how much remains unknown. When we look into the night sky, we are not simply observing distant stars. We are looking into the history of the universe itself. Each photon collected by Webb has traveled across unimaginable distances before reaching its golden mirror, carrying information from a time long before humanity existed. Those ancient signals are helping us understand where galaxies came from, how stars evolve, and how planets capable of supporting life may form. The greatest mystery, however, may not be a single object or a hidden signal. It may be how much the universe still has left to teach us. Every observation brings us one step closer to understanding our place in the cosmos. And as long as humanity continues exploring, asking questions, and following the evidence, the next great discovery could be waiting in the very next beam of light captured by the James Webb Space Telescope. Because in science, the most exciting answer is often the one we have not discovered yet.